All right, welcome. So this is the last, I think, lesson of this unit, and then we really need to keep moving forward. So the next lesson, the new unit will be algebra. So that's kind of exciting. All right, so this one, I can find the missing number with equivalent ratios. I think it'll be pretty easy, you guys, because I'm thinking in my mind, the setup for ratios is a lot like fractions and finding an equivalent fraction either by multiplying the denominator numerator or dividing. So just a vocabulary word, equivalent ratios, have the same value. Okay. Hey, just remember, some of you before were having trouble pausing. I'm okay too if you just want to watch it once to get the big picture. Maybe it's less frustrating and then go back and rewatch it and the second time will make sense. Okay? Oh, all right. To find the missing number, I'm actually going to demonstrate this kind of the easy way, but I'm also going to demonstrate it the pre-algebra way because I want you to know why it works. All right? So equivalent ratios mean that the same numerator has the same ratio or proportion as the denominator. And I don't even know if in ratios you call them numerators and denominators, but I'm going to just still use those words as far as their place. Okay? So, step one, the easy way, I look at that 9 and I think to myself, what do I have to do to the 9 to make it a 36? And hopefully you already know your fact families. If you're not sure, you can always say 36 divided by 9, but hopefully we remember that to get from 9 to 36, you just multiply times 4. Again, if that's not obvious to you, then do 36 divided by 9 to see what that number was. Then if the bottom part of the ratio you have to multiply times 4, then do the same thing for the top. So 4 times 4, an equivalent ratio would say 4 parts to every 9 part is the same as 16 parts to every 36 parts. Okay. All right. Looking at the next one. Oh, I see the 50 in my first ratio has to be equivalent to something that's actually smaller. Hopefully you recognize that that's just a divide by 2. If you don't, try it. 50 divided by 25 and you'd get 2. But whatever happened to the bottom part of the ratio has to do the same thing in the top part of the ratio. So 6 divided by 2 is 3. All right. I am actually going to erase this because some of them won't be as obvious, or sometimes they'll have decimals in there. So I do want to show you the algebraic way of solving it. So give me a second to erase. And here's how to solve it algebraically. So look here, we have 4 and 36 across or diagonal from each other. So step one, multiply the two numbers that are diagonal from each other. 4 times 36 is 144. Now, other years I had students who always said, my parents showed me an easier way. Yep, that's true, you guys, but I'm trying to prepare your brains for the next unit where it's going to be pre-algebra. So yes, the easier way would just be, boom, take the other number and divide by 9. It'll work. That's what we're doing. But to set it up algebraically, we'll say, oh, well then, we've done this before, the butterfly. 9 times x would be 9x. And we're still saying we want to solve what times 9 is 144. And yes, that easier way was just to divide. So you'd say what's happening to the x because they're side by side, that's being divided. So 9 divided by 9 is 1. Now we have x left over. But if I divide on the right, I have to divide on the left. And 144 divided by 9 was 16. So guys, oops, that should be a 6, sorry. Yes, there will be an easier way. Oh my goodness, I'm making it worse. There will be an easier way, but I do want to at least present the algebraic way so that you'll get used to that. Let's do it a little bit faster on the side. Step 1, multiply the two numbers are right across from each other. 6 times 25 is 150. Yep, the easy way is just take that other number and divide. 150 divided by 50 was 3. But so that you can start thinking of it algebraically, 50 times x is 50x. Divide by 50, divide by 50, x equals 3. So can I just say for this unit, take the easy way. Certainly take the easy way. Multiply the numbers that have something right across from them. Divide by the third number. For those of you who like the challenge of processing algebraically, go for it. Okay. All right, next slide. Ooh, so think positioning. Think, hey, the 7 is positioned to the left of the colon. So what we're looking for is also to the left of the colon. So then the two numbers to the right of the colon are where you're thinking, what made the change? For example, what did I do to the 35 to get 105? And guys, if that isn't obvious, I would do the larger number divided by the smaller number, and I got 3. So it must be that 35 times 3 will get me that 130. 35 times 3 will get me 105. So then whatever you did to those two, do to the first two. 7 times 3 is 21. So this spot should be a 21. Okay. Same thing. Keep your positions. The number to the right of the colon, the number to the right of the colon, and you're thinking, ooh, what happened to get from 72 to 36? Let me try dividing. 72 divided by 36. Oop, we got a 2. So because the number got smaller, we must have had to divide by 2. Oh, I didn't think this one through. Whoops. So now we're going to do 9 divided by 2, and we get 4.5. Sorry. Let me write that a little bit larger. That number is 4.5. I would use my calculator on that one, guys. Whoops, sorry. Let me try to make my decimal bigger. So think, what number could I either multiply or divide to get the second number? Oh, let me see if I can just quickly move this if you need that. Oh. All right, last, or do we have 2 more slides? Word problems. For every can of paint, Sue can make 2 fences. Here that is a ratio. For every can of paint, she can paint 2 fences. Did they really say the number 1 here? No. But let me just make that just more straight. For those of you who straight lines matter, I get it. For every can of paint, she can paint 2 fences. Here that as a 1. Every can of paint sounds like a 1. All right. How many cans? So be consistent. If cans was on the top the first time, then how many cans will she need to paint 10 fences? Both times the number of fences were in the denominator or the bottom. So then I would think to myself, what did I do to get from the 2 to the 10? Times 5. So do the same thing on the top. 1 times 5 is 5. Now last slide. Ooh, changing this to a decimal. She can read 2.5 pages for every 10 minutes. So think 2, I would change it to a decimal. 2.5 pages, so it sounds like pages is on the top, for every 10 minutes. How many pages can she read in 30 minutes? So now you're thinking, what did I do from the 10 to get to the 30? Times 3. So then do the same thing in the numerator, 2.5 times 3. Go ahead and use your calculators, and it would be 7.5. So she can read 7.5 pages in 30 minutes. Pretty sure that was my last slide. Yep. Great job taking notes. Come back and show me your video notes.